In the early 20th century, governments, engineers, and agricultural planners were captivated by a simple idea. What if a single tree could solve multiple national problems at once? Imagine a tree that grows faster than almost anything in the temperate world, up to 15 feet in a single year. A tree whose wood burns hotter than many types of coal. A tree capable of thriving in poor soil, resisting pests, and regenerating from its own roots even after being cut down. To industrial planners and survival-minded homesteaders alike, such a tree appeared to be a miracle resource. It could provide fuel, timber, erosion control, and rapid reforestation. For countries recovering from war, economic collapse, or environmental degradation, it seemed like a gift from nature. But within a few decades, that same tree was banned or heavily restricted in several countries. In parts of the United States, planting it can still be illegal. The reason reveals something deeper than a simple environmental mistake. It shows how good intentions, when paired with incomplete understanding, can reshape entire ecosystems, and how the search for energy independence sometimes creates problems far more difficult than the ones it was meant to solve. The tree at the center of this story is the Paulownia, often called the Empress Tree, and its history is a quiet lesson in how survival solutions can turn into long-term liabilities. The Paulownia tree first entered the West through trade routes that carried more than just goods. Paulownia trees are native to central and western China, where they have been cultivated for centuries. In traditional Chinese agriculture, the tree held a practical and symbolic role. Farmers planted Paulownia alongside crops because its deep root system did not compete heavily with surrounding plants. Its large leaves enriched the soil as they fell, and its wood, lightweight yet strong, was prized for furniture, musical instruments, and construction. In Chinese culture, Paulownia also carried symbolic weight. It was sometimes planted when a daughter was born, the tree growing alongside her until its wood could later be used in furniture for her households. But in the 19th century, global trade transformed the tree's destiny. Paulownia seeds began arriving in Europe and North America through shipments of porcelain and silk. The tiny seeds were often used as packing material, protecting fragile goods during long ocean voyages. When those crates were unpacked in ports like New York and Philadelphia, the seeds scattered into the surrounding soil. Within a few years, an unfamiliar tree began appearing along railroads, riverbanks, and disturbed ground. At first, botanists treated it as a curiosity. Then, people began noticing something remarkable. The tree grew with extraordinary speed. Industrial societies quickly recognized the potential of a tree that grows faster than forests. The late 19th and early 20th centuries were periods of aggressive industrial expansion, and, well, timber demand was immense. Railroads required wooden ties, mines needed timber supports, and cities demanded lumber for construction and fuel. Traditional forests could take decades to mature, but Paulownia, by contrast, could reach usable size in a fraction of that time. Under ideal conditions, young trees could grow 10 to 15 feet in a single year. Within 10 years, they could reach heights that many hardwoods required 30 or 40 years to achieve. Equally important was the wood itself. Paulownia burns hot and clean, making it attractive as a fuel source in regions where coal was scarce or expensive. At the same time, the wood's low density and resistance to warping made it useful for construction and transport applications. For policymakers thinking about long-term resource security, the tree appeared to offer something rare: rapid, renewable energy and timber production. During the 20th century, several countries began exploring large-scale Paulownia plantations, and for a time the results looked promising. But the same qualities that made Paulownia useful also made it difficult to control. Fast growth is rarely neutral in ecological terms. Paulownia trees produce enormous numbers of seeds, often millions from a single mature tree. Those seeds are extremely light and can travel long distances on wind currents. Once they land in disturbed soil, they germinate rapidly. Rail corridors, construction zones, abandoned farmland, wildfire areas and floodplains all become ideal territory. The tree also regenerates aggressively from its roots. Even if cut down, it can send up multiple new shoots within a single season. In controlled plantations, these traits make the tree resilient and productive. But outside those boundaries, they allow it to spread quickly. By the mid-20th century, ecologists began observing a pattern. In parts of North America and Europe, Paulownia was escaping cultivation and establishing wild populations. Native plants struggled to compete with its rapid growth and broad leaves, which cast deep shade over surrounding vegetation. In some ecosystems, the tree began altering soil composition, moisture levels, and plant succession patterns. What had been introduced as a resource was gradually becoming an invasive species. Eventually, governments realized that managing the tree required much stronger intervention. Environmental policy rarely moves quickly. In most cases, ecological damage only becomes visible after decades of gradual change. By the 1970s and 1980s, several regions in the United States had documented the spread of wild Paulownia populations across forest edges, cliffs, and river valleys. The tree proved particularly adept at colonizing areas disturbed by landslides or, honestly, just human activity. Once established, it could dominate early-stage forest regeneration. This raised a concern familiar to land managers everywhere. Invasive species rarely remain confined to the environments where they first appear. Some states began classifying Paulownia as a problematic invasive plant. Regulations soon followed. In certain jurisdictions, planting it intentionally, especially outside controlled agricultural settings, became restricted or even illegal. The goal was not to erase the tree entirely, which would have been nearly impossible. Instead, the objective was containment. Limiting new plantings reduced the risk of further ecological spread. For policymakers, the decision really reflected a difficult balance between economic opportunity and environmental stability. The irony here is that Paulownia is still considered a valuable resource in many parts of the world. While some countries restrict the tree, others actually cultivate it quite aggressively. In China, where the species evolved alongside native ecosystems, Paulownia remains an important agricultural asset. Farmers often integrate it into crop systems because its canopy allows sunlight to reach the ground more easily than many other trees. Japan has long valued Paulownia wood for traditional crafts and cabinetry. In recent decades, Australia and parts of Southeast Asia have also experimented with commercial plantations. The global interest really reflects the tree's genuine advantages. Paulownia wood dries quickly, resists warping, and maintains strength despite its low weight. Some modern builders even use it in specialty applications like lightweight structural panels and surfboards. From a survival perspective, the tree offers something equally valuable: renewable fuel and rapid biomass production, but those advantages depend heavily on careful management. Without oversight, the same characteristics that make the tree productive can, in fact, disrupt entire landscapes. The deeper lesson here is about how survival solutions must be evaluated over generations, not just years. Many resource decisions are driven by short-term urgency. A country facing energy shortages, deforestation, or economic recovery often looks for rapid answers. Fast-growing trees like Paulownia seem to provide exactly that. But ecosystems, they operate on much longer timelines. A species introduced today may reshape landscapes 50 years later in ways that are difficult or even impossible to reverse. The history of Paulownia really illustrates a pattern repeated many times in environmental policy. Solutions designed for resilience sometimes create new vulnerabilities. For survivalists and planners alike, the lesson is straightforward. A resource that appears efficient in the short term must still be evaluated for long-term consequences. Growth rate, fuel output, and adaptability matter, but so does ecological compatibility. The difference between sustainable cultivation and uncontrolled spread often lies in careful boundaries. Understanding this history, I think, reminds us that preparedness always involves trade-offs. The appeal of the Paulownia tree has never been difficult to understand. A fast-growing source of fuel and timber has obvious advantages in times of scarcity. In another context, another ecosystem, it might have remained simply a useful agricultural species. Instead, it became a case study in unintended consequences. Today, the tree still grows along American highways, cliffs, and abandoned lots, its purple spring blossoms standing out against the landscape. Each one is a reminder of an earlier moment when a promising solution arrived without a full understanding of its impact. History is full of such moments, and, honestly, studying them carefully is one of the best ways to avoid repeating them. If you value thoughtful, in-depth explorations of overlooked historical lessons like this one, consider subscribing to Logistics of Survival. And if you found this story worthwhile, share the video with someone who appreciates history that goes beyond the surface.